Hi one and all, and fractions, decimals and percentages, today's topic. Can't wait. As I said previously, fractions, I don't know, I remember doing fractions at school myself. And being a maths teacher, you think, well, I must have found it easy. But no, not at all. Fractions to me were somewhat confusing, as were decimals and percentages. But I'm here to try and help you sort this out. And if we look at our key questions for today, it's what is a fraction, what is a decimal, what is a percentage, and how do I change between them? Now, what I didn't put there is why you would want to change between them. Lots of different things in maths try and trick us. And one of the best ways that maths exams and tests can try to trick us is they say, write a particular question in a particular way. So, for example, it might say, write your answer as a fraction. It might say, write your answer as a decimal. And if you don't, sadly, you actually lose all the marks, even if you have the right answer. So, without much further ado, which is a fabulous British expression, let's kick into this. So, what is a fraction? Now, we've done this before where we said that actually 3 over 8 means 3 out of 8, right? So this little thing here is the same as out of, or on a calculator, it's the divide button. So 3 over 8 is exactly the same as 3 divided by 8. If we go back to our chocolate example, for those of you who've seen the chocolate video, it just means that I am eating 3 out of every 8 pieces of chocolate. And in that situation, there's just the 3. A fraction is actually just, realistically speaking, just saying it's a small part of something. So what are the different types of fractions? Well, we have all sorts of different fractions. We have a half, we have a quarter, we have 3/4. We might have, I don't know, 1.5. That's a fraction, it's a mixed fraction, right? But we can turn that top heavy by turning it into, say, 3 over 2. Now that's fascinating. All this actually means is 3 halves. Right? It does not mean the same as 3.5. It means that I've got 3 halves. Another way of writing this would be 3 halves. And for those of you who come back to the idea of multiplication of fractions and stuff, you can run away and do that. But that's not what I'm talking about. So fractions can come in all sorts of different ways. But we actually really like them when they're written in a sort of a normal way, even when they're top heavy. If we have 10 over 7. Now, one of these things I'm going to try and teach you now is that maths, remember, is a big, fat trick. And as such, we can actually let's write down the whole number 3. And I'm going to say to you, is that a fraction? I'm waiting for your answer. And obviously I can't hear you. But the point of it is 3 can be written as a fraction. How? Well, any whole number can be divided by 1. So I should start the question, what's 3 divided by 1? 3. Well, what about 4? Well, that can turn into a fraction as 4 divided by 1. By dividing by 1, you're not actually changing the size of the fraction. So it's a pretty valid thing. If we have 10, I can write 10 over 1, and 100 over 1. So just to warn, or just as an idea, if you're trying to turn a whole number into a fraction, just divide it by 1. So here is a fraction. What about a decimal? Well, actually, fractions, decimals, and percentage are all related. And if you can go from one to the other, I think you'll find Year 7 and Year 8 maths and Year 9 and Year 10 and VCE and A-level and everything that you might be doing actually really easy. A decimal is just that. It is a number that has a decimal point in it. So 0.3, 0.5, 1.2, 0.34796, that's a long decimal, 3.141592. This one here is a really cool decimal, but we'll come back to later on, maybe in Year 9. All of these are decimals. They have decimal numbers in them. I can even go 0.0003. That's a decimal. As long as it's got a decimal point in it, that's a decimal number. Now, later on in maths, we need to know about things called decimal places. And I might as well just do a quick one here, because then you can come over as like really, really awesome at maths. Decimal places are the number of digits, so it's the number of digits that actually sit after a decimal point. So if we actually look at the examples we've been given, this one here actually has 4 decimal places. Wow, this one here has got 5 decimal places. Notice what I'm doing. I'm writing DP, which is actually short for decimal places. This here has 1, 2, 3, 4, 5, 6, 7. 7 decimal places. And these have all got 1 decimal place because they've got 1 number after the decimal. And again, in some maths questions, the numbers after the decimal are really important. So let's just recap. We've got these things called fractions, which have a number, this divided sign, and a number, one on top of the other, otherwise known as numerators and denominators, but we'll come back to that later. We have these decimals, which are numbers with decimal points in them. Now, interestingly, we then have percentages. And percentages, let's talk about some of the percentages you already might know. You know, you go shopping and what would you see? You'll see a sign that says 50% off. And you go, wow, I must get a PS4 now. It's got 50% off in it, like governor. Right? 20% off. 10% off. Or on a recent electricity sign I saw, 0% off, which I thought was really random. We also meet percentages in chance, right? And obviously this is the module that this lesson sort of normally fits in. So probabilities. And we would have 0% as being impossible. And we'd have what would be the possible or certain one? Certain would be 100%. And again, as a side note, lots of people think that the 100% is the highest percentage you can actually have. I'm going to tell you now, probably not. Right? In year 7 and 8, you actually can get 200% and 300% and 500%. But again, let's not run away. That's for a later lesson. And so 50% will be even chance. Now, sometimes we can actually get decimals in our percentages. So when you do a test, sometimes you'll be marked out of, let's say you got 10 out of 20. Well, you got 10 out of 20, you got half of them right. And so a quick calculation or somebody memorizes things will say, well, you got 50% right. But when you maybe get things like, 13 out of 17, the chances are you're going to end up with some sort of decimal number. But written as a percentage, you can still have 52.31%. Yes, it's got a decimal number in it, but this little thing here, this little percent says, actually it's a special type of number. So that's the introduction to fractions, decimals, and percentages. Now let's try and work out how we convert from one to the other. Now when we convert, it means we just change. And I think the best way to do this is probably, if you're allowed to, just use a calculator. Oh, no, a maths teacher said use a calculator, please. It's the end of the world. Move on, move on, move on. But no, actually, if you're allowed to use a calculator, use a calculator. You may as well get it right. Yeah, mental arithmetic is important, don't get me wrong, but so is actually getting the answer right. So here is a fraction. Let's call this example number 1. It's 1/2, otherwise known as a half. Well, I said earlier, and this is the second lesson, where I can actually say that that can become 1 divided by 2. But how do you do 1 divided by 2? Let's go back. You guys have been taught how to do longhand short division. Blah, that's a bit of a mouthful. So let's see, what does that mean? I'm trying to do 1 divided by 2. And it's really important there that you get the order right. Notice that the 1, this first thing here, is inside my bracket. Right? It's inside that division sign. And the 2 is outside. So the thing on the bottom, the denominator, is always the one that goes outside. Now, I already know that 1 does not divide by 2. So I'm actually going to put a decimal point and a 0 there, because I know I'm going to end up with a number smaller than 1. If I have 1 sweetie, and I'm going to divide it amongst 2 of my friends, the chances are it's going to be that we're going to get a half each. We're going to get smaller than that whole one each. Now, if you're going to share things, make sure it's not gobstoppers or anything that they would put in their mouth first. The transfer of germs is quite disgusting. Don't do it. But back to this question here. So the first thing I say is, does 2 divide into 1? Does the number 2 go into 1? Well, we already know it doesn't. It goes in 0 times with a remainder of 1. Where did that 1 come from? It came from just here. I moved the decimal point up, and because I've put the 1 here, I can now say 2 divided by 10. No, 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 no. Lots of people say that the wrong way. It isn't. It's actually 10 divided by 2. How many? 0. It's 0.5. Was there any remainder? No, there wasn't. And so, ladies and gentlemen, that is my answer. So 1/2 becomes equal to 0.5. Let's do another example. Let's call this CG2. 1/4. Oh, I changed the language. Again, maths is trying to trick us. We have different language. That's the same as 1 divided by 4. So, which one goes outside? Yep, the 4 goes outside and the 1 goes inside. And I know it's going to be a decimal number, so I'm going to put the decimal point and I'm going to put a 0. And in fact, even if it didn't go a whole number or there was bigger numbers, I can still put that 0.0. It's not going to hurt. It might just help me. So the question is, does 1 divide by 4? No, it doesn't. It goes in 0 times remainder 1. So I put that little 1 above the 0. Does 10 divide by 4? I should think so. It goes in 2 whole times, but now there's a remainder 2. Now, obviously, back in junior school and younger years, you'd have gone remainder 2 and we'd have just called it a day. We'd have gone, thanks very much, I'm finished, moving on. But yeah, sadly, not here in secondary school or in year 6. We can actually do something with that in a different way. So remember, we had a remainder 2 because 2 times 4 was 8. So we have remainder 2. And I'm going to write a floaty 2, but oh my goodness, there's nothing there. What? Yes, there is nothing there. So I'm now going to put a nothing. That now looks like it's the number 20, which I say, can that divide by 4? And yes, 4, 8, 12, 16 and 20 gives me 5. Is there any remainder? No, there isn't. And so that is my right answer. 1/4 becomes equal to 0.25. Lastly, but by no means least, e.g. 3. Now remember, this becomes 3 divided by 10. And as such now, there are 2 different ways of doing it. The first way is the way that we've just been doing. Let's stick to that. Let's have a go. So let me think. We've got 3 divided by 10. Decimal point and a 0. So, does 3 get divided by 10? No, it doesn't. Put a 0 there and it carries 3. This number now becomes 30 and we divide that by the number outside. 30 divided by 10. How many 10s go into 30? There's 3. With a remainder? Nope. So I now know that 3 divided by 10 is equal to 0.3. But if you remember back to a previous lesson, anything that's divided by 10, 100, 1,000, actually is just our bouncing decimals. So we can move our decimal 1 place to the left. So there is my 3, there is my secret spy and my 0, because obviously we have to have that psychic. I'm going to move that decimal point 1 place to the left. There is my new decimal point. So if I write the decimal point and there's the 3 and there's the 0, we can't have that floating decimal point. That spy needs some backup. He needs to be protected by the 0. And if we know anything from previous stuff, we can put as many zeros after this as we like. It's actually not going to change the number. And so we can ignore all of those zeros. Otherwise, we'd be writing them forever. So once again, 3 over 10 is equal to 0.3. Oh, smiley face. All right, ladies and gentlemen, something for you to do if you want to have a go. There's some questions to be done for you now. Pause the video and have a go. And then we'll come back and just check that you got the right answers in just a moment. How did you get on? Assuming that you have stopped the video and done all these fabulous questions, right, let's just see. 1/2, 0.5. 1/4, 0.25. 3/4, 0.75. 1/10, 0.1. 2/5, wow, 0.4. This one was 0.7. 1 over 8, 0.125. And 9 over 10 is 0.9. Now, you're probably saying to me, wow, you must have had a calculator beside you when you did those. Sadly, I did not, or thankfully, I did not. Lots of these fractions, actually this one and 3/4 and 1/10 and 2/5 and 7/10 and 9/10 are actually fractions that you are really encouraged to memorize if you can. All right? Because they're going to make life so much easier. But moving on. Turning a decimal number into a percentage. So we've gone from fraction. We know how to turn a fraction now into a decimal. Oh, decimal. We're now looking at turning that decimal into a percentage. And if you remember, a percentage has to have that little percent sign after it. Now, it's no real surprise. Actually, if I rearrange this, this looks like a slash and a 0 and a 0, which looks surprisingly like 100. And that's actually part of where percentages come from. Percentage, per, actually, the letter per means out of. And the word cent actually means 100, or can stand for 100. So percent means out of 100. And what we're trying to actually do is write numbers that will have a out of 100, or can be expressed as out of 100. But we're running ahead of ourselves. This is coming soon. So here's an example. Let's turn 0.9 into a percentage. Now, the great thing is to turn a decimal number into a percentage. All I need to do is multiply by 100. Mind blown. How on earth is that possible? Well, more on that in a moment. Sorry, just had a cup of coffee. Thank you very much. So, I'm now going to multiply that by 100. Do I need to use some fancy maths? Does my head need to explode with this? Absolutely not. Because again, when you multiply by 10, 100 or 1000, you bounce decimals. Now, because we're timesing, we're going to go that way. We've got 2 zeros, so I'm going to move 2 places. Here is my 0.9. There's my new decimal point. So let's write these numbers out as we should now. The 0 and the 9. We jumped over nothing, so there's a big fat nothing there. Put my percent sign, because we know that we've actually got to do that. And no, something doesn't look quite right with that number, does it? We don't need to write the leading zeros. And so 0.9 as a percentage is 90%. Well, this doesn't seem particularly complicated, does it? Turning decimal numbers into percentages. Well, let's just do another example to make sure we've all got it sorted. Turning this is currently a decimal, remember? I don't want it as a decimal, or for some reason I need to change it into a percentage. So to do that, what do? I times by 100. So doing some working out, and you're going to say, well, I can do that in my head. Many of you will be able to. I always do my working out. So I do need to do that, and I'm going to times by 100, which means I'm moving my decimal point 2 places that way. Why 2 places? Because of the 2 zeros. So 0, decimal point, and the 3. There's my new decimal place. Let's write the number 0, 2, 3, decimal point. Do I need to write that decimal there? Nope, because it's at the end. Secret spy can now go back to being secret. And what about this 0? Well, we remember that trailing zeros do not need to be written. And so I must make sure I write my percent sign so that I know that 0.23 can be expressed as a percentage as 23%. Wow. Okay, zipping through this now. Questions for you to do. Press pause if you want to. Have a go at the questions, and I'll come back in a moment with your answers. How'd you get on? Right, okay, well here are your answers. So 0.3 became 30%. That became 67%. 90%. 23%. Now this one was a tricky one, but 36.9%. Wow! Yeah, I wonder how many of you fell over on this one. It actually worked out to be 120%. And if you remember from before, yes, you can have numbers more than 100%. This one, 99%. This one was a trick. How many of you got tricked? It was just 3%. And this one was an even bigger trick. Jumping that decimal point puts you actually just before the 0, just before the 2. So you actually got 0.21%. And one last tricky one. 1 became 100%. If you're not sure why, remember, 1 can be written as 1.0. Jump it once, jump it twice, and there you'll find you have your 100%. All right, joining it all together. Wow. Have a go at trying to write the following fractions as percentages by writing them via a decimal first. Again, pause it, have a go, and if you need to, come back and I'll tell you how the answers were. All right, so how did you get on? Yep, right. Did you pause it? No, you're just still listening to me, aren't you? So write the following fractions as percentages by writing them as a decimal first. So 1/2 as a percentage was actually 50%. 3/5, when I write that as a decimal, becomes 0.6, which becomes 60%. 6/10 becomes 60%. 4/5 becomes 80%. 1/4 is 25%. 75%. 9%. Now actually this one here is actually really important. This one here is 63%. Again, what do you notice about the bottom number? And this one here, we've already done this one. You should have just been able to copy the answer from above, is 100%. Now, as I say, big fat tricks with my little magician. Sometimes we can make fractions into percentages without having to turn them into a decimal first. That has to be a big smiley face. If we can make the bottom of the fraction into the number 100, hold on a moment. We've said that percent means out of 100. And we know that this little divide sign here can also be written as out of. So 9 out of 100 is exactly the same as 9%. If I can make the bottom of my fraction divided by 100, I can actually write this top number here as the percentage. Wow, mind blown. Before we go a little bit further, we just need to do one thing called equivalent fractions. All right, so if we look at this here, we've got the half. Can we write that in a different way to still mean the same fraction? Well, yes, I can actually turn that into 2/4. How? Because remember, with fractions, what you do to the top, you can do to the bottom. So if I multiply the top by 2, then I must multiply the bottom by 2. And so long as we do that correctly, we find that 2/4 is exactly the same as a half. And in fact, I could multiply that by 2 on the top and 2 on the bottom and get 4/8. Are they the same? They absolutely are, because 4 pieces out of 8 is the same as 1 piece out of 2. And if we did our colouring in, we'd find all this out. Sometimes we want to be able to turn a half into a fraction that we have a known bottom or a known denominator. And we know that for percentages, that's true if we can get this divide by 100 on the bottom. Well, if I'm trying to keep it equivalent and I'm trying to keep the numbers in the same ratio, how do I get from 2 to 100? You could say add 98, please don't. How about timesing by 50? And so if I times the top by 50, my half turns into 50 out of 100. But we know that divide by 100 is the same as writing percent. And so 50 out of 100 is the same as 50%. Mind blown. So what about the following fraction? Well, if I've got a 10 on the bottom, how do I go from 10 to 100? Yeah, I multiply by 10. And because it's a fraction, do the top and the bottom exactly the same thing. So 1 times 10 is 10. I know that anything with divide by 100 can be replaced with a percentage sign. And so I now know that 10 over 100 is just 10%. Last one. 100. How do we get from 20 to 100? Oh yes, we times by 5. And as such, 7 times 5 is 35. And so I can go straight to my answer and write that as 35%. All of the fractions above can be turned into a different fraction with the numbered 100 at the bottom. So, just to check, half and 1 over 10 and 7 over 20 can be turned into 50 over 100, 10 over 100, and 35 over 100, which makes them easy to turn into percentages. Right, last thing for you, write the following fractions as a number out of 100 by using equivalent fractions. Off you go. Press pause and have a go. And then I'll check back in just a second. Hi guys, welcome back. Did you pause? Well, it's me again. So let's see, what did you get? 4 out of 10. Writing them out of a number out of 100 first becomes 40 out of 100. Why? Because I times the top and the bottom by 10. This one here, 80 out of 100. What about a half? Well, I already did that one for you, 50 out of 100. This one here, if I multiplied the top and the bottom by 4, I get 12 out of 100. Had to worry there, really couldn't remember. This one became 18 out of 100. Now, this was a trick. Do you see what I did there? I made the bottom too big. So how do I go from 1,000 to 100? This one here, I have to divide the top and the bottom by 10 to give me 83 over 100. Ooh, 1. Remember, that's the same as 1 over 1, which becomes 100%. Oh, no, try that again. Wrong exercise, Darren. This is equal to 100 over 100, because that was what the question wanted. And this one here, times by 5. What's 13 times by 5? And that will be 65. And the last one here, how do I get that? 20. So that will be 60 over 100. I'm going to leave these to you to have a go, following fractions as percentages, and hopefully what you'll notice is, if you look at the questions here, hopefully what you'll notice is that all I've actually done is try to trick you by moving the questions above around. So you should be able to take your answers from the previous and write them straight as percentages. Okay, that's the end of this lesson, or the end of this video, or the end of whatever this is. I look forward to seeing you next time.